All right, so we just finished looking at simple ionic formulas, and now we're going to look at complex ionic formulas. And I want to show you how complex differs from your simple ionic formula. So let's look at this. All right, and you probably need to write this down as notes. All right, so following along. So if we look at where we were, what we've looked at, okay, what we've seen so far is you have the name calcium nitrate and you go to your ionic charges chart, okay, and for calcium you see that as Ca2 plus and nitrate is NO3 -1. And I think it's safe to assume that most of you like the crisscross method. So in order to write the formula, you're going to bring down the Ca and the NO3. And then from there, just the number, like this 2 here, becomes the subscript outside of the NO3. And that understood 1 becomes the de facto subscript behind the Ca. Okay, and when you rewrite that, you get Ca. We don't write the 1, it's understood. And then we want to show that there's 2 NO3s. So we put it in parentheses, NO3, and then put the 2 outside of there. And so that's what we've been doing. Okay. How does complex differ from that? Well, the complex ionic formulas are made up of your transition metals. And so these are formulas that have elements from the groups 3 through 12 from the periodic table, as well as 2 elements from group 14, which would be lead and tin. These elements can form multiple oxidation numbers. So you could see 2 plus, you could see 3 plus, you could see 1 plus. Some of them go up to 7 plus. All right. But how do we differentiate between, iron that has a charge of 2 plus versus iron that has a charge of 3 plus? We put Roman numerals in the name. And so that's the only thing that's different from what you did previously. Okay, we have Roman numerals in the name. Take a look at your pink sheet. And take a look at your positive ions at the top. All right. You see, let's look at column 1. Gold 1, copper 1, lead 1. Okay. And then you go over to the second column. You see lead 2. All right. And where's copper? Copper 2. Okay. So in your pink sheet, it's already been given to you this information. And now we're looking at how you use that. All right. Let's look at what I do. Let's look at how the names will look. All right. Is there anyone still copying this? You good? Let's look at how the names will look. So if you look here, our first example, we have iron 3 sulfide. Now let me tell you how you're going to use this. This 3, that Roman numeral 3, that is the charge on the iron. So that means I put the symbol, that 3 means that iron has a charge of 3 plus. If you don't trust yourself enough to know that the Roman numeral is the same as the charge, then come here. Find iron 3, and you look over to the side, it's Fe 3 plus. All right. The second part, look at the bottom part of your pink sheet. You find sulfide, is S2 negative. Okay. From there, we just do the crisscross method. Okay. We're just going to do the crisscross method to write our formula. And so using the crisscross method to write the formula, what will you come up with? So using the crisscross method, your formula will be Fe2S3. Let's look at our next example. We have lead 4 oxide. Okay, so this Roman numeral here tells you what? What is the purpose of the Roman numeral? Yeah, it's going to tell you the charge on the lead. So it's going to be Pb 4 plus, and then oxide. So you go to the chart and you find oxide to be what? O2 negative. All right. And then once again, we're just going to use the crisscross method to write the formula for lead 4 oxide. And so what would, and I want this simplified. So what would the answer be using the crisscross method to write the formula for lead 4 oxide? All right, so Pb2O4, is that the simplified version? If I look at this 2 and that 4, can I simplify it? Can I reduce those numbers? And what will that become? There you go, PbO2. All right, so as you can see, writing complex formulas is a whole lot like writing the other formulas. You just get a leg up where you have Roman numerals that tell you the charges. All right, so we got some practice problems that we're going to work on at this time.